The universe has the potential to reach a temperature of absolute zero, the coldest possible point where nothing could be colder. What is absolute zero? Absolute zero or 0 Kelvin is the temperature at which a thermodynamic system has the lowest energy. On the Celsius temperature scale, it is equivalent to 273.15 degrees Celsius, while on the Fahrenheit scale, it is equivalent to 459.67 degrees Fahrenheit. In the lab, scientists have gotten very close to reaching absolute zero. A small quantity of rhodium metal was cooled in 1995 by scientists at the Massachusetts Institute of Technology (MIT) to a temperature that was just 1/1000th of a degree above absolute zero. The lowest temperature ever recorded at that point was this particular one. A glass of water was cooled to just 5/1000ths of a degree above absolute zero in 2003 by University of Colorado at Boulder researchers. This is the liquid's coldest temperature ever recorded. A cloud of atoms was cooled in 2009 by researchers at the Joint Quantum Institute (JQI) to a temperature that was just 4/50 of a degree above absolute zero. This is the gas's coldest ever measured temperature. Although absolute zero is frequently considered to be the theoretical limit, it's possible that we will someday be able to achieve it in a lab. However, some physicists doubt that we will ever achieve true absolute zero. For centuries, a key component of our understanding of physics has been the pursuit of absolute zero, but this has never been accomplished. We've used cryocoolers, refrigerator dilution, and nuclear adiabatic demagnetization to create temperatures as low as 0 degrees. It has been observed that absolute zero is not possible. In the coldest regions of the universe, a system's entropy will always be higher than zero because it would take an infinite amount of work to remove all the heat from a substance. In spite of the fact that absolute zero is still only a theoretical idea and an unrealistic target, scientists are still learning more about the characteristics and behaviors of matter as they get closer to this extremely unusual and fascinating temperature. But if the world plunged into this impossible temperature, even if it's just for a minute, what will happen? First off, let's talk about temperature. In Antarctica in 1983, the planet's coldest ground temperature, 184 degrees Kelvin, or -89.2 degrees Celsius -128.6 degrees Fahrenheit, was measured. However, it is a long way off from absolute zero. Even the Boomerang Nebula, 5,000 light-years from Earth and the coldest known location in the entire universe, is only slightly warmer at 1 degree Kelvin. The kinetic energy of the particles in any item is measured in terms of temperature. It reveals the velocities of atoms, molecules, and subatomic particles. The particles travel more quickly when a gas, liquid, or solid becomes hotter. And the slower the movement, the colder that stuff gets. Particles cease to move completely at the lowest temperature imaginable, referred to as absolute zero. Air molecules move at an average speed of 1,800 km/h, 1,118 miles per hour at room temperature, which is that cozy range of temperatures around 293 degrees Kelvin. As the Earth's temperature suddenly dropped, all of those particles would begin to slow down. At 1 × 10⁻⁵ Kelvin, the atomic particles would be moving at a speed of about 0.18 km/h, 0.11 mile per hour. In comparison to the speed at room temperature, that is 1,000 times slower. All chemical reactions would be getting closer to stopping entirely as we get this close to absolute zero. This is due to the fact that there is no heat energy left at 0 Kelvin. And if that were the case, you and everyone else on Earth would be in dire straits. Everything happens as a result of chemical reactions. Absolute zero temperatures would be horrifyingly cold. As the temperature approaches absolute zero, many materials undergo drastic changes in their properties. For instance, gases can become liquids, and some liquids can become solids as temperature decreases. Oceans made out of water will transform into massive lands of ice, and even magma will transform into solid rock. Gases in our atmosphere such as nitrogen, helium, oxygen, hydrogen, and even methane will liquefy. Such gases aren't inherently harmful, but combined with the already freezing temperature, direct contact with these in their liquid form can cause severe cold burns and frostbite. They can't be avoided unless you went all the way to outer space, since such gases exist in the air itself. Ignoring the danger the gases possess, with all matters stopping, that includes the particles of your body. It would be extremely dangerous and potentially fatal if all of your body's functions stopped for even a minute. Our body's various systems must function continuously and in unison to keep us alive. When vital processes stop working, there may be serious repercussions. You would lose consciousness almost immediately, as all chemical reactions in your brain that produce thoughts stop, your heart would stop beating, breathing would halt, and your body temperature would drop significantly. Your body would start shutting down rapidly, and before you even know it, you would have died. A minute of absolute zero may as well cause a mass extinction of life. If the temperature dropped to absolute zero, all matter would vanish. This is due to the fact that all particles would have zero kinetic energy and be unable to move or interact with one another at absolute zero. There wouldn't be a universe if there was no matter. But I have good news: while you still won't survive, there's a small chance that the chemical reactions wouldn't completely stop. Chemical reactions do seem to be occurring even in the Boomerang nebulas near absolute zero temperature range. This is due to the peculiar results of quantum physics. Also, anytime quantum physics is involved, strange things tend to happen. The Earth's atoms would begin to clump together when they were all at a near stopping point. They would be creating what is known as a Bose-Einstein condensate, a state of matter. This would imply that, from a physical standpoint, every atom is in the same energy state and is therefore essentially the same. They would begin to act like a single atom. And it would be quite amazing if you could turn into a Bose-Einstein condensate. You would possess some special physical characteristics for those brief moments of absolute zero. Similar to superfluidity, you would be able to flow without resistance through small cracks. However, there wouldn't be any cracks because there would be other superfluid objects on the planet in addition to you. But there's a problem. Only when bosons are cooled to nearly absolute zero can Bose-Einstein condensates be created. Atoms with an even number of electrons make up all bosons. The implication is that only a small subset of the atoms in your body and the environment could undergo Bose-Einstein condensation. Luckily, until now, absolute zero is still merely an idea, so there's no need to have anxiety towards all of this. It is quite a fascinating concept to let your mind wander into. Was your attention caught by this story? Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.